So we are going to do the last review for the pre-grade 11 stuff, and then expanding on solving equations is one of them. We did talk a little bit about simplifying equations or simplifying expressions, pardon me, and we talked about like terms and what are like terms. Okay, what do you guys remember about like terms?
Yeah, right, same exponents.
They have the same exponent and same variable. Okay, and then what do we do when we're adding and subtracting exponent? What must we have? Sorry, adding and subtracting terms, like terms. What do we add and subtract? The coefficient. Perfect. So when we're collecting like terms, we're going to add or subtract the coefficient of the terms. That have the same exponent and variables. Okay, so 2a plus 3a, they are like terms, right? Because they have the same letters, same exponent. 2a plus 3a, I just have to add the coefficient, and I'll leave the term, the variable as is. So that's going to be 5a. So this is what I'm adding and subtracting. Okay? So if I have 3a minus 2b, take away 5a plus b, what do I collect? 3a minus 5a, which is negative 2a. Remember that I don't want the equal sign at the end. Usually the equal sign is at the beginning or in the middle. Okay? So if you have an equation, it will be in the middle. If you have an expression, it will be at the beginning. So negative 2a. And then if I have negative 2b plus b, negative b. Right? You can write negative 1b, but the proper way to write it is negative b. Okay? That's the most simple form. I can't do anything with it, so I leave it. Okay? 2x squared plus 3x, take away 6, take away 4x squared plus 5x plus 7. What are my like terms? 2x squared and negative 4x squared. So you see that I'm only adding and subtracting the coefficient. I'm not touching my terms. I'm not touching the variables. Okay? Then you have plus 3x plus 5x. Negative 6 plus 7 plus 1. Okay, that's a thing. I'm adding and subtracting terms. Now, if I have multiplication, then if I have a, do you guys know what binomial mean and monomial mean? Polynomial, anything like that? No? Okay. So, here are the terminologies. So, a term, it's called a term, right? When I put two terms together, or we call it monomial. So if I have, let's say, 3a, right? We call that a term. Or we also call it a monomial because it means it's one term, right? Mono means one, and well, that's one term. If I have two terms added together, as long as these two terms are not like terms, right? So if I have, let's say, 2a plus 3b, right? These two terms are not like terms, so I can't add them. That means I have two terms here. This becomes a binomial because it's two terms. So we call it binomial. If I have three terms, So for example, 2x squared plus x plus 2, right? So you see I have 1, 2, 3 terms. I can't add them. We call that a triangle. Okay? And then for the rest, we call them just polynomial because we can't keep specifying. Okay, so if I have 4 terms, 5 terms, 6 terms, whatever, we call them polynomial. Even from the binomial further, they're called polynomial because they're more than one term. Okay, but these have more specific names. Okay, so more than 3 terms or more than 2 terms, they're called polynomial. Called like binomial if they're two unlike terms. They can't be like terms because otherwise you can add their coefficient and make them more. Okay, so if I'm looking at distributive property, I have here, what do we call this in the bracket? How many terms do I have in the bracket? 2 terms, so what do we call that? Binomial. Okay, so I have a binomial and it's multiplied by a mono. Okay, so what you're going to do, you're going to multiply each term of the binomial. So each term of the binomial by the mono. Okay, so you're going to multiply this by the first term, and then you're going to multiply the A by the second term. Okay? So we call this the distributive property because I'm distributing that term into the terms inside the bracket. Okay? So this is AB because A times B is AB plus A times C is AC. Okay? Let's see at that example here. So what do I have here? I have a monomial, which is negative 2a, multiplied by a binomial, 3a minus 2b. Okay? So I'm going to have to multiply that monomial by both terms inside the bracket. So what's negative 2a times 3a? Negative 6a squared. Okay? Remember at this time we are multiplying. Okay? So negative 2 times 3 gives me negative 6. And then a times a is a squared. Okay? Let's look at the second one. So I'm multiplying negative 2a by negative 2b. Negative times negative? Positive. 2 times 2 is 4. How about a times b? AB. Okay, let's read this. So that says 2x minus, open bracket, x, take away 8y, close bracket, take away 3y. How can I simplify this? That's right. So in this case, that negative is in front of this bracket, so that negative is going to affect everything inside the bracket. Okay? You're going to pretend it's a negative 1. 1 that's there. All right? So, that's going to be 2x. Take away x. And then plus 8y, because negative times negative is positive. Take away 3y. Are we okay with this? Now I'm going to look at my like terms. What are my like terms? 2x minus x, which is x. And then 8y, take away 3y, 5y. Now this is the case I have a monomial multiplied by a binomial. Okay? If I have two binomials multiplied by each other, then I'm going to follow similar method, but it's called the FOIL method, okay? Which means you're going to distribute the first term in the first bracket by both terms inside the second, and then the second term, you're going to multiply it by both terms, okay? So this is called FOIL for a reason, because if you see here, I'm going to multiply my first term by my first term, right? So we multiply, F stands for first, so multiply the first terms in each bracket together. Okay? So that would be A times C. Then I'm going to multiply the outer terms. Okay? So the outer terms, that's why it stands for O. Okay? 1T or 2T? I don't know. Looks wrong, but 1T? Okay. Now, so I'm going to multiply my first terms, then my outer terms. Okay? I stands for inner, yeah, the inside terms. So my two inside terms, right, the ones that are in the middle, and then L stands for last, okay? So that means the last term from the first bracket times the last term of the second bracket, okay? So as long as you remember that you're going to have to multiply the first term by both terms and the second term by both terms. So let's see what does that give. A times C is AC. A times D. B times C. And then B times D. Okay? Now, in this case, I don't have like terms, but be careful for like terms, okay? If you have like terms, you're going to have to collect them to simplify, because we call this expand. So you're expanding it, and then you're simplifying. Let's look at the first example. So, what are my first terms? 2a times negative 3. So I'm going to multiply 2a times negative 3a, so that's negative 6a squared. My outer term, so 2a times negative 2b, my inner terms, so 4b times negative 3a, so that's negative 12. BA or AB doesn't matter. Doesn't matter. BA, AB, it's the same thing, right? So I'm going to write it as AB just so we can relate it back to the previous term, okay? And then negative 8B squared. So if I'm looking at this, do I have any like terms?
Yeah.
Yeah, so my two middle terms are like terms, so I'm gonna simply add them together or subtract in this case. So negative 6a squared, take away 16ab, take away 8b squared. All right, so let's look at the next one. What do I do?
9x.
Okay, so again, binomial multiplied by a binomial, so I have to FOIL. So I'm going to multiply my first term together, so that's going to be 2 times 3, that's 6. X squared times x is x cubed, okay? Because you already have an x squared multiplied by another x, that's going to make it x cubed to the power of 3, okay? And I'm going to multiply the outer, so that's going to be 10x squared. Multiply the inner, so that's going to be negative 3x squared. And last is negative 5x. Any like terms? The two middle terms. So 10x squared minus 3x squared is 7x squared minus 5x. Are we okay with this? You're going to see this again when we go to quadratic. You're going to see that we have to FOIL, we're going to have to expand, simplify, collect like terms, things like this. So you're going to have to get used to that. So I want to finish the lesson. I'm going to give you time to work on the worksheet. So we're going to go from expanding and simplifying to solving, okay? So whenever I'm solving a linear equation algebraically, I'm going to have to isolate for the letter that is there, okay? So if the letter is, let's say, M, I'm going to have to isolate for M. If the letter is X, I'm going to have to isolate for X. So I'm going to leave it on one side, move everything else to the other side. But there's rule with that. You can't just move anything anywhere, okay? We have to follow the rules. So first you're going to eliminate any fractions by multiplying each term in the equation. I'll explain that in a second. By the lowest common multiple, okay? So LCM, lowest common multiple. Which means in this case, if I have a fraction, I want to make sure that I have a common denominator under all the terms. That's what it means. On both equality, because then I can eliminate that fraction. Now sometimes it can simply be, like in this case, for example, for B, it can simply be just cross multiply, right? Because I only have one fraction. But in the case like if I have D over 7 plus 3 equals to 2, for example, if I have something like this, I can't cross multiply. I have to make sure that I have a lowest common multiple for all of them. That means I have to make sure that this has a denominator of 7 and this has a denominator of 7 before I can eliminate my fraction. Okay? Things get complicated when we're solving, but in this like, we'll look at different examples, but these are not the only examples. All right. Eliminate any brackets by using the distributive property, right? You can't move things around when they're in brackets. You have to release them from the brackets before you can move them around. And then you're going to rearrange the equation. To isolate the variable and solve. So how do I choose, or like when I have something like this, for example, let me just give you a simple equation, okay? Simple equation, right? Linear, the simplest that you can probably have, okay? How do you decide, if you're gonna isolate for this x, how do you decide which one to move first? Which one to, because you're gonna have to get rid of the 3 and you have to get rid of the 2, okay? How do I decide which one do I get rid of first, the 3 or the 2?
You keep all our variable inside, so
Mhm.
what let you will move it to another side.
But how do I decide that I'm gonna have to move the 3 first and not the 2?
Because the 2, I have to remove it, I need division.
Mhm.
1, 3 is only to subtract.
That's
It's
right.
easy to do it subtract before, like opposite.
We're gonna have to do opposite operation. Yeah. But why do I have to do? Why is it not right? It's not right to divide by 2 first and then move the 3. Why? That's my question.
It will be a little bit hard to divide it into 2 and then distribute 3 to times 2 and move it.
It's not only hard, it's wrong. It's wrong. You have to do like a lot of math in order for you to do proper math. Not only math, right? A lot of students, they want to get rid of the 2 first, and that's wrong. So what we have to use, we have to get rid of the numbers with using the reverse BEDMAS method. Okay? So when you're doing BEDMAS, so if I give you a number for x, so if I give you x, give me a number for x.
1.
Okay, so if I tell you x is 1, what does BEDMAS tell you have to do first?
To get rid of the bracket?
So that means you have to do 2 times 1,
Yeah.
right? First. Then,
To addition.
Add. So the first thing I have to do is I have to multiply the 2 times the 1. And then I have to add the 3, right? So with BEDMAS, I have to do this first, then this second, right? When I'm isolating, I have to move backward, okay? So when I'm isolating, I have to isolate this one first, so I have to remove this one first. Then I have to remove this one. Okay? So you're thinking about BEDMAS. What does BEDMAS tell me? You do the opposite. You get rid of them in the opposite direction, opposite way. And that's what use BEDMAS backward means. Do opposite operation, right? So when I move from one side of the equality to the other side of the equality, I'm going to have to do the opposite operation. Addition, subtraction, subtraction, addition, multiplication is division, division, multiplication. And, or, some of them they say, what do you do to one side, do to the other. So that's the same thing as do the opposite operation. Don't worry about this one. I don't usually show you this way. first example. Or actually, you know what? Let's look at this one because that's an easier example, and then we'll move to A, B, and C. So, for this one, we said that the first thing I have to get rid of is this 3. So I have to bring the 3 to the other side. And because it's an addition here, it's going to become a subtraction. So that's 2x equals to 2. And then I have to divide by 2, right? Because I have 2 times x. So for me to get rid of that 2, I have to divide by 2. And that gives me x equals 2. Okay? This is the simple way, simple form. How about this one? What do you want to do for that?
I have to rid of the denominator by multiply m.
Multiplying by
m.
So, do you guys agree with that? Yes? Do we agree with multiplying by m? I do. So, what I have here, I have 12 divided by m equals to 3. When my denominator is an unknown, okay, you want to bring it always to the numerator. You don't want the letter to be in the denominator. Okay? So, what you want to do, you want to bring this division to the other side and make it multiplication, because the opposite of division is multiplication. So I have 12 equals 3m. Okay? Opposite of division, multiplication. Are we okay with that? All right. Now, I have 12 equals 3m. I want m by itself. What do I do? Divide by 3. Because you want to get rid of the 3 now, so you're going to bring it over, right? It's a multiplication here. When you bring it over, it becomes a division. And what's 12 divided by 3? Is 4. So your answer is m equals to 4. Okay? Now, I want you to always ask yourself the question, does that make sense in my equation? So if I take this and plug it here, 12 over 4, what does that give me? 3. So it's correct. That's how you check your work. Okay. So 2d plus 1 divided by 7 equals to 3. Get rid of the denominator first. How do you get rid of the denominator first?
Multiply 7 by 7.
Okay. You see in this case, the good thing is that the whole equation is divided by 7. Because the whole equation is divided by 7, I can actually bring it over to the other side as a multiplication. Okay? So, that means I can get rid of that division and then multiply 3 by 7, because the opposite of division is multiplication. So I have 2d plus 1 equals to 21. What's next?
So I have to isolate the d.
And how do I do that?
By moving the 1 the other side.
That's right. So remember, we move the addition first. So that's going to become subtraction. So then I have 2d equals to 20. Then I have to
10.
divide by
2.
2. And that gives me 10. I'm writing all of these steps because I want to show you guys what is happening. You technically, if you want to skip like this step, for example, the d equals 20 over 2, that's fine, as long as you give me the right answer. What would you want to do for this one? Yeah, so distribute the negative 3 in, yeah.
And the same as the other side for this.
And distribute the 4 in, right? So remember, I can't move anything anywhere until I do my distribution, okay? Until I get rid of the brackets.
So you can repeat it again? What did you have to do?
So I can't move anything around until I distribute. So this is called distribution by multiplying this by the negative 3 by everything inside the bracket.
It means the same, get rid of the brackets, right?
Yes,
Oh, okay.
but it's called distribution because yeah. So you see that in the previous slide. Yeah, you see we did that.
Under this one, so-
Okay, so it's called distributive. So I'm gonna have to multiply that negative 3. Don't put an equal sign because there's already an equal sign in the middle. We don't put an equal on the outside. So negative 3x minus 6
Minus 3x.
minus 3x equals
8
8.
minus 20x.
So I'm distributing, I am multiplying. Okay, let's collect like terms. But remember that I have to stick with my side, okay, for now. Do I have any like term on the left side? Okay, negative 3x and negative 3x, that gives me negative 6x. Now what do you want to do?
Together, let's call together the x together.
Bring
Put
the
x.
like terms to one side, okay?
Like
So
terms
bring
and-
the x's to one side and bring the constant to the other side. Eyes on me for a second. You see how there is an x on the left and there is an x on the right. And you see how there is a constant on this side and there is a constant on the other side. I need them to be on the same side. So I need the x's to be on one side and I need the constant to be on one side so I can add them. Okay? So I have to move the negative 20x over. When I move a negative 20x, what does it become?
Plus-
Positive. Because the opposite of negative is positive. Okay? Now at the same time, I'm going to move the negative 6 to the other side. Okay? So they're switching spots. So I have 8, negative 6. When you bring it to the other side, it becomes a plus 6. Now, you see that I have the like terms on one side, so I can collect them. 20x minus 6x, that gives me 14x equals to 14. What's my last step? Divide by 14. What do you guys want to do with D?
Find lowest common denominator.
Yep, I can do that, so I can find the lowest common denominator. That's one way. Or the other way.
Or cross multiplication.
Okay, it's the same thing, right? So, eyes on me for a second again. Because all the numerator is divided by 3, all the numerator divided by, so the whole side is divided, right? I can do cross multiplication. The minute I have something like this, for example, if I have this, for example, I cannot do cross multiplication. Okay? In order for me to be able to do cross multiplication, the whole side has to be divided by that number. Okay? So, in this case, I can do cross multiplication. I can multiply the 4 by the y minus 7 and the 3 by the y minus 2. So, 4 times, you see my brackets? They're important because that 4 is multiplied by the whole y minus 7. Equals to 3y minus So what do we want to do now?
Distribute.
Distribute. So 4y take away 28 equals to 3y take away 6. So I distributed by multiplying that monomial by the two terms of the binomial. So what should we do? Bring the like terms to the same side, right? So 3y, I have to bring it here. And negative 28, I have to bring it to the other side. So I have 4y minus 3y equals to negative 6 plus 28. Stop me if you're having problems. So now, because I have the like terms on the same side, I can collect them. 4y take away 3y, that's just y, equal to 22.
I have a question. So the lowest common multiple is 12.
Correct.
I started with multiplying both with that, but you can skip that step in the answer and then just go straight to
Cross multiplication.
full bracket.
I did cross multiplication. So basically what you can do also, so if you have y minus 7 over 4 equals to y minus 2 over 4, that's over 3. So if you want to do a common denominator, right, which is 12, right, that means I have to multiply this by 4, and I have to multiply this by 4, right? That means I have to multiply this by 3, and I have to multiply this by 3. Okay? So I'm going to end up with 4 times y minus 7 over 12 equal to 3 times y minus 2 over 12. Okay? Now, because both denominator on both sides of the equality is 12, they cancel each other out. Okay? So they cancel each other out, right? And then you're going to end up with my first step. Okay? So if you do cross multiplication, in this case, right, you can, then you're skipping this step. Okay? We're just skipping a step. We're good? Does that answer your question or no?
Is this wrong? How I did it is wrong. It's okay.
Yeah, that's fine. That's another way. Yeah,
Okay,
that's
okay.
fine. There's multiple ways. All right.